So thank you to Vessel AI. Thank you to SVB. Welcome, everybody. So today I'm going to talk about a topic that I think many of you may know already, but we're going to level set with this first talk so that the talks that come after kind of make sense. So even if you know some of this stuff, that's totally fine. Just bear with us as we build out the basics so that people who don't kind of feel comfortable moving forward. So we're going to talk about RAG, or Retrieval Augmented Generation. And I'm going to cover, roughly speaking, 4 topics. So we're going to talk about LLMs, why they're good, why they're bad, what the limitations and capabilities are. Then I'm going to talk about what embeddings are and how they work. I'm going to talk about what a vector database is, and then I'm going to explain how Retrieval Augmented Generation works in the context of a vector database. And if there's time, we'll walk through a little bit of code. So let's start by talking about LLMs. So as we all know, LLMs are phenomenal tools. They've been introduced in the last couple of years, maybe 3 years, to the people who were really like starting up with GPT-2s, and they're not showing any sign of stopping. Right? They're getting better all the time, but we do know that they have some inherent limitations that come with this deal. So let's look at like the things that we know that LLMs are good at, and the things that LLMs are bad at, to kind of set the scene for why we even need RAG in the first place. So LLMs are trained with vast amounts of data that allow them to accomplish a variety of very intricate tasks. They could seem to sometimes do some sort of reasoning. Now, obviously, there are people who would say they're just stochastic parrots. Some people would say, actually, they are doing some level of reasoning because they need to have some quote-unquote mental model of the world and an understanding of the world. So I think the jury is out on whether or not they're actually doing reasoning or not. What we do know is that they're very good at extracting knowledge from existing knowledge, right? So if we give them a piece of information and then we require them to answer questions about that information, they're, for the most part, pretty good at doing that, right? If we're asking them to generate information without providing that sort of context, we're running the risk of what is colloquially known as hallucination. And they're also really good at summarizing things, which should tell us a lot. So summarizing something isn't quite trivial as it may sound, right? In fact, it requires that the thing that is doing the summarization actually understands what's relevant and what's not relevant to the person asking for the summary, right? And so I would claim that like the summarization task actually shows a lot of quote-unquote reasoning capabilities right there. So where do LLMs not really perform for concrete real-world use cases? So LLMs, by definition, don't know anything about our data. And by our data, I mean our company's data, our own personal data. They don't have any exposure to that, and we have to sort of expose them to that in order to elicit any kind of response that would make sense in that context. They're very good at making very plausibly sounding responses to our questions, but we can't know for sure that those are real answers, those correct answer or factual answers, because the LLM cannot prove to us that what they said is true, right? We don't know how confident the LLM is in what they're saying. They're just saying it. We're just getting that long concatenated string of text that it spits back at us. But we cannot know for a fact that the LLM was tapping any particular data source that is trusted and verified by us, right? To say that this is true or this is not true. And finally, I would say that this may be like the biggest Achilles heel and kind of like one of the manifestations of how LLMs kind of fall short is that they don't really know how to say, I don't know, right? And that is unless they've been really targeted and trained to do this specific thing by someone. This is called what is called an RLHF, or reinforcement learning from human feedback. So unless that has happened and the LLM has been trained to actually do that and say, I don't know, like if you ask me about like how to make a bomb, right? We can't expect the LLM to say, I don't know, right? Just by itself. Okay. So in this talk, what I want us to kind of try and do is to think about LLMs in a little bit of a different way than what we usually maybe think, right? So instead of going to ChatGPT or whatever and saying, yeah, ChatGPT is my oracle and it knows everything I need to know and it will give me all the answers, let's think about the LLM as not being the source of truth. Let's instead think of it as sort of almost a natural language interface that allows us to use knowledge in all sorts of ways and shape it to the shape that we want to consume it in. And that means that we have to give the LLM the context it needs to provide us with value, right? We can't just assume it has it. We have to provide it to it. And once we do, we can then rely on its ability to summarize, to deduce from that information, and to actually give us value to the questions that we're posing it. Okay, so the question then becomes, how do we do that? Like, how do we connect like our world, the things that we want, the things that we're asking about, the things that we mean with the LLM? What's the bridge? So the answer to that is, in short, embeddings, and I'll just explain very shortly what embeddings are. So essentially, embeddings are like kind of a cornerstone of all of the things that we've seen in the last couple of years or 3 years, right? They're essentially an internal representation of neural nets that take objects from semantic space, like words or sentences or paragraphs and so on and so forth, and they embed those objects in vector space. So we take words on one side, the embedding model does its work, and on the other side comes a vector. Now, the thing that is preserved in this process is the meaning of those objects in the semantic space, preserved in the vector space. And that kind of manifests itself in the way that we can sort of think about visualizing embeddings in vector space. So here is a very, very simplified kind of representation of what happens to terms that we take from semantic space and embed into vector space. And basically what happens is that terms that carry the same semantic meaning are going to be closer together in vector space. Now, vector space is usually highly dimensional mathematical space, and that means that there are not just 3 axes to this visualization. In fact, there could be many thousands of those, right? But the calculation still remains. We basically can apply similarity metrics to a set of vectors to determine whether or not they are similar to one another. And in practice, it means whether they are actually close in vector space to one another, right? Okay. Now, a vector database, and this is where Pinecone comes into the picture. The vector database is there to allow us to store a big collection of vectors and then perform queries on this big collection of vectors in the same way that we would otherwise perform queries on documents or queries on rows, right? What we provide to the vector database is a query vector. What we store in the vector database is vectors that we want to query. And then when we perform these operations, the vector database can efficiently do these similarity comparisons and give us back for our query vector what are the result vectors. So basically oh, that's a bummer. Am I out? It says that I'm connected. Thank you for the heads up. No. Not connected. All right, I mean, we don't really need this, it's fine. We can keep going.
You're back here, I think that'd be fine.
Okay, yeah, so whenever this will come back, we'll have a good time with it. But in the meantime, I'll just tell you about Pinecone and stuff like that. Okay, so as I was saying, the vector database basically allows us to not think too much about how we're going to get back these vectors, these similar vectors to what we're requesting, right? And why is that helpful in the context of RAG? We'll get into that in a second. Just as a quick aside, just because we have time to kill, right? I'll tell you a little bit about Pinecone. So Pinecone is meant to be a scalable vector database, right? The main goal here is to make sure that no matter how many vectors you have, these similarity queries are going to happen in the fastest time possible, and that the cost will also not scale linearly or exponentially, right? So to keep those costs low, and of course to allow all of the things that you would expect from any other database, so to be enterprise ready with like all of the SOC 2 compliances and whatnot, and HIPAA and whatnot, and all the multi-tenancy things, and of course to be easy to use, right? So you don't have to deploy anything. You just you just sign up, and you're good to go. You get a key, and you're good to go. Okay, and we have this back. Perfect. Okay, so. Okay. Okay, so let's talk about RAG. So what happens in a RAG application? So the RAG application allows us to connect these two worlds, right? The LLM and the user and the trusted and our trusted data, right? The core kind of challenge here is that whenever a user has a query, right, it's going to be semantically ambiguous, right? So if we wanted to sort of build RAG with, say, I don't know, like a normal relational database, right? Or just any kind of search engine, right? We would be reliant on this search engine's capability of actually getting the most relevant documents back into the context. And because, again, like the interactions, for the most part, in a RAG applications are of a chat nature, right? You'd expect people to kind of be loosey-goosey, not really try to go and find a particular keyword that they're trying to target, right? They're just going to ask their question. And so in that context, our ability to serve them with semantically relevant content that takes into account this ambiguity is going to be very helpful. So how do we do this? We basically use the embedding models to take our content, the things we care about, and generate vectors out of that content, generate embeddings. These vectors are also called embeddings. We store those in the vector database. We then take the user's query, we embed that as well, and we use that embedding to query the database. And now we get back references to documents that are semantically relevant to what the user has asked, and we can take those documents and we can inject them into the context of the LLM. And that's basically saying, putting them in the prompt, right? So we basically tell the LLM, here's a question, the user's question, then we take the content that we retrieved from the vector database, we plop it in there, and then we tell the LLM, based on this content, please answer this question. And here we have, again, a situation where we're no longer reliant on the LLM just inventing things, we're pointing it to a very particular context that we know is relevant and trusted. And we can also provide proof that these are the sources that we used in order to answer this question. So now we've gone from this world where we don't know exactly why the answer was the way that it was. We actually do know exactly what the data sources are, and the user can follow them and see for themselves. And we also have the ability to say, I don't know. And the reason for that is because every time we get back, we query the database, we can decide where the cutoff is in terms of our confidence in the context. Meaning, I can say, if I got results with a low confidence, that means that like the query that the user has provided me doesn't have anything to do with the knowledge base that I've embedded. And so I'm going to say, I don't know, this knowledge doesn't exist in my system. right? And that is a key capability to sort of protect our companies, our solutions from providing information that is potentially devastating, right, to a user and to a company. I'm going to touch on metadata a little bit later if we have time, but I'm going to skip over that just to give you a little bit of an idea of what does it look like in practice to stand up a RAG application. So a RAG application has two steps, as I mentioned. The first is ingestion, and the second one is the query step. So we take, in here you can see we take our data source, we usually chunk the data that we get, and that is because, for the most part, people usually, right, operate with documents. It's not very effective to take an entire document and embed it, and for that reason, we're going to break it down into smaller pieces. And there are many, many ways to do that, and if you want to talk to me later about all the ways that there are to chunk, I'll be more than happy to tell you. There's also like an article about that on our website. We then take those chunks, embed those chunks, and upsert them into the vector database alongside with metadata that is relevant to those chunks. So for example, a metadata that could be relevant is if I took a document and I broke it up into 10 chunks, I can have the parent document from where all of these chunks have been created referenced in that metadata. And of course, I can reference any other kind of metadata that I care to reference at that point. Okay, so now we have a bunch of vectors in the database, and each one of those vectors has some metadata associated with it. The next step in our application, we take, again, the user's query, we embed it using the same embedding model. We can use what's called a metadata filter alongside with our vector embedding. Again, that is the user's query, but in an embedding form, right? And we can now query the API, right? So in that point, basically, I can say to the metadata filter, hey, please give me documents, but only ones that have been created in the last week, right? That's an example of like a metadata filter that you could use, right? But you can imagine whatever metadata you used to write this information into Pinecone, you can use it as a filter to filter your results when you're querying it. Then again, we call the API, we get our query results. At that point, we can do all sorts of things with those results. So for example, a common thing to do is to re-rank those results, and there are re-ranking models that allow you to, again, serve a more optimal final result to stuff your context with. Those results are then passed to the LLM's context, back to the LLM, and then we stream back or return back the results from the LLM to the application. I'm not going to go, because I think we're running out of time here, I'm not going to go over this in super detail, and I'm assuming that this talk is going to also be available online. But I just wanted to give you an idea of the different tools that exist in the ecosystem for RAG. We've discussed like taking the data source, processing the documents, doing document segmentation or chunking, doing the embedding generation, and then upserting it to Pinecone. Like I said, the other side, in the application, we have retrieval, re-ranking, the embedding generation for the query side. Two things that I think are important to note here are evaluation and monitoring. So there are a plethora of tools to do that. One that I think is super important to mention here is RAGAS. RAGAS is an open source framework for evaluating your RAG pipeline. Basically what it does is it takes your documents that you created, it generates for those documents a set of questions that are relevant to those documents, and based on those questions also generates a set of answers, and then runs the entire RAG process that you've created on the same data set of questions and ground truth answers, and basically compares those two to see if the RAG pipeline answers and the ground truth answers are actually the same. And we lost that again. That's cool. All right, so to close it off, I think we'll just take a couple of questions and then we can move on to the next speaker.
I'll just talk loud. We have 5 minutes for questions, so I will see if I can get this mic working, and if so, then I'll run around and hand. But if you want to shout out in the meantime.
Can you talk about Pinecone's organizations? How it integrates with open Microsoft and other LLM
Yeah,
action
so
points, right?
in general,
Just in general.
yeah, so in general, Pinecone has 2 offerings. One is serverless and one is what we call pods. Pods are essentially being phased out because they're not as cost effective and as scalable as serverless. And serverless, and both serverless and pods are both what I would call just like very shortly enterprise compliant, right? So, you know, you could use them in any kind of SOC 2 or HIPAA compliant kind of situation. And I would say, you know, in terms of like what LLMs you could use with it, what other tools you could use with it, Pinecone in general is agnostic, right? So it doesn't really care. You just give it vectors, right? If you can give it vectors, you could work with whatever tool you want.
Okay, we're going to go with this gentleman, and then you in the back. I saw you had your hand up. So
I heard there was a hybrid search available from Pinecone. Is it past the beta preview? Is it in production?
Not
when
yet,
is it going
not
to be
yet.
available?
Not yet.
It's been a year.
Yeah, it has been a year. It is available on pods, and but there's sparse boosting in beta in serverless, but not yet in production yet. Yep.
Hi, more of a generic question, but I guess when do you think it's better to use RAG versus fine-tuning an LLM?
Right. I think that like it really depends on your use case. I think that if you need the ability to answer highly domain-specific questions that do not exist in like any LLM off the shelf, and you value the ability to basically answer those questions over your ability to prove their correctness, then you should probably go with a fine-tune. Know that it's usually more expensive and cumbersome to do fine-tuning, although not always, right? Like there would be those who would tell you that it's not that hard. I personally think that it is. I think that RAG has like the virtue of being explainable more than an LLM is on its own, whether it's fine-tuned or not, right? The ability to pull on the source and say like, I built this, I'm giving you this answer based on this particular trusted source is unique to RAG. Yeah, for sure, for sure. Like I think that like the more modalities you use, the better. Like I think that there are a lot of cases to be made where semantic search makes more sense for a set of problems than vector search or semantic search. Those cases usually are more, cases where you have more domain-specific things that wouldn't be embedded properly by an off-the-shelf embedding model. And in those cases, you might want to use a custom fine-tuned embedding model, right? Which is its own thing.